Hey folks, so as you've heard, we are doing review in class today. I know I'm not here, that makes review a little bit more challenging, but I am asking that you finish the front and back of this sheet. I cut down the problems a lot. There's about 2 in each section, and they're all the things that you need to know for this test. Now sometimes when there's a sub-in, you guys don't always get done what you need to. We are going to be testing next block. There is no way that I'm going to say, oh, we're going to put our test off for a whole time because it wasn't in school. No, you have this sheet, and I'm going to go over probably about 4 or 5 problems on this sheet to kind of get you started, okay? I know I might get made fun of for doing another lesson video, but I'm not here, so I don't have to hear you make fun of me. So let's take a look at this sheet, and let's start with one of the ones that have to do with graphing. So our first problem, they give us A, B, and C. Right now, cross B right off. I'm not going to make you do a table of any of these equations. I just want to know that you can graph it, okay? So you can cross off B. So as we solve 9, really what we're going to do is we're just going to graph this equation, okay? We're going to find our y-intercept, our axis of symmetry, and our vertex. Those are the first things we did in this unit when we started. So we have x squared plus 5x plus 12 equals 0, or f of x. Again, we can set f of x equal to 0 or y, whatever you prefer working with. 2, graph this. We first want to get our y-intercept, which is very easy. Our y-intercept plus 12. It's always our c. Next, we want to get our vertex. Now, vertex we've had practice with. We use our vertex formula to get just the x value of our coordinate pair for our vertex. Our vertex formula is negative b over 2a. So I take my b, negative 5, over 2 times my a here is 1, so 2 times 1. This simplifies down to a negative 5 over 2. If I pulled out my calculator, that's going to be negative 2.5. Okay? I'm going to take that value, I'm going to plug it in here. That way, I can get my y value. Remember, your vertex isn't just one point. It is a point, but it has a x value and a y value. It's a coordinate pair. So I'm going to take this negative 2.5 and I'm going to square it. I'm going to then add to it 5 times negative 2.5. And then I'm going to add 12 to it to get my y value. I actually have to grab a calculator, so hold on one second. So through the magic of movie, I've done all the work for you. If you want to, and I suggest you do, pause it, grab a calculator, and make sure your numbers can match mine. So negative 2.5 squared is a positive 6.25. 5 times a negative 2.5 is a negative 12.5. Remember, we can just make this a minus right here. And then lastly, we add our c onto it. I already did that workout. That gives me 5.75 as my y value on my coordinate pair for the vertex. Not the y-intercept, but the y value for my vertex. Now that I have my y-intercept and my vertex, I'm going to graph this up. The directions do not say I have to do the x-intercepts, okay? It just says find these and graph it. So I don't need to do that piece in this specific example. So if I'm going to graph it, I need my y-intercept to be at 12. We'll just do a quick 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right there. It hits at that axis. We'll do a few hash marks this way and that. So I'm going to go to negative 2.5, 1, 2, 2.5 would be here. I'm going to go up to 5.75, 1, 2, 3, 4, 5, there's 6, so it's going to be just a little bit less than that. Okay. Remember, in the directions, part A, it says, draw your axis of symmetry. This is my axis of symmetry. Make sure you draw it in. From this point to my axis is 2.5, so I'm going to go 2.5 over, there's half, 1, 2. Go up, put my dot. This is my graph, okay? If I were asked to find the x-intercepts for my graph, it is obvious that I don't have any, okay? What that means is if I do the math to get my x-intercepts, I'm going to get imaginary solutions. This is where our i's or our complex numbers come in. But for number 9 on your sheet, show this work, write it in, okay? 9's done, try 10 on your own now, okay? From there, we're going to do with number 13. Which I really think isn't too bad, but it requires that you know and remember some stuff we've talked about. They give you a function, f of x, and again, this is 13, equals negative x squared plus 3x minus 1. Okay, we have this. And the question is, find out whether it has a maximum or a minimum and what the value is of that max or min. So here, looking, I'm going to ask myself, is it going to be a U shape or an N shape? Take a second, try to remember. The way we figure this out is we look at our A value. If A is negative, our shape is going to be an N. If it's positive, it's going to be a U. If it's negative, it's going to look like that. That has a maximum, okay? Because there's some value it cannot go above. Although it seems weird that the negative has a maximum, that's how it works, okay? Don't think negative automatically minimum. Usually if it's a negative here, in fact, every time if it's a negative here, it has a maximum. So to find that max, look at it. It's the vertex. So we're going to do our vertex formula to get that coordinate pair for it, okay? So vertex formula, negative b over 2a. We just did this. Negative b is negative 3 over 2 times negative 1, so negative 2. Negative over negative is a positive. 3 over 2 is 1.5. That's my x value. Now I'm going to take that value, I'm going to pause it. I'm going to figure out all of my chunks here by plugging it in. I'm going to have negative of 1.5 squared. Again, we apply that negative after we square it. Do your exponent before your multiplication. Plus 3 times 1.5 minus 1. So, hopefully you pause me if you need to. Grab your calculator. 1.5 squared is 2.25. I applied the negative after, so it's negative 2.25. Plus 4.5 minus 1. If I do that all out, I get a positive 1.25, which is my y value here. Okay? So, when they ask me for my maximum, all right, I told them it's a max because it's going to be upside down. I drew a little picture. I thought about it. My max is going to be this y value. Okay, if you give me the whole coordinate pair, I'm cool with it because I know you did the work. I know you can find it. But again, the y value is what they're really looking for. So that same thing is what you're going to do for 14. Okay. Lastly, let's do one of 16, 17, or 18. Okay. Here's where they want you to graph the whole shebang, including the roots. Now, roots are the exact same thing as solutions, the same thing as zeros. All of those words are synonymous. They mean the same thing. So let's take a look at, let's do 18. It has the most highest coefficients in it. So we have 4x squared minus 6x minus 15 equals 0. We have to find our y-intercept. We have to find our vertex if we're going to graph this. And we also need to find our x-intercepts. Okay, they do ask you in this specifically to state the exact roots, which means our solutions or our x-intercepts. So, y-intercept, negative 15. Vertex, negative b, which becomes a positive 6 over 2 times our a, which is 4. So we have 6 over 8. I feel like we're dealing with the fractions a lot here. 6 over 8 is the same as 3/4. If I divide it out, it is 0.75. Now I'm going to plug in that 0.75 here. So I'm going to do 0.75 times 0.75. I get some funky decimal. I'm going to multiply it by 4. I'm going to round that. Actually, you know what? It's 2.25, so I'm going to keep it like that. Minus 6 times 0.75 is 4.5. Minus 15. Now I'm just going to solve that and stick it in as my y value. So 2.25 minus 4.5 minus 15. Negative 17.25. To find our x-intercept, we have 3 different strategies we could use. We could factor, which this one won't work because I just tried it and had to restart the movie. The other strategy that we could do here would be completing the square. That's hard because our a is 4. The last strategy that we could use would be to use our quadratic formula. Okay, so the quadratic formula is what you would actually use on the last couple problems on this paper on the back side. So if you want to pay attention now, that'll help you solve those also. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. This needs to be memorized. Okay, there's no negotiating. At this point, you're ready for the test. We practiced this a bit. I really want you ready for it. I want you to know it by heart. So we're just going to plug in values. Negative b becomes a positive 6 plus or minus the square root b squared is going to be 36 minus 4 times 4, which is my a, times negative 15. All over 2 times a, which is 4, so 2 times 4 is 8. This gives me 6 plus or minus the square root of 36 minus, actually it's going to be a plus because a negative times this negative is going to be a positive. And we have 4 times 4, which is 16 times 15, 240 over 8. Now 36 plus 240 is 276. I'm going to check and see what that is square rooted on my calculator. Again, I could stop here, but I want to continue going because I need to graph it, so I need to know at least approximate decimals. So I'm going to second x squared to get my square root, type in 276, and I get it 16.6132, blah, 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 blah. So I'm going to keep it as 16.6. When I solve this, folks, my square root goes away, and I'm left with two possible solutions. I have 6 plus 16.6 divided by 8 as my last step, or 6 minus 16.6 divided by 8. Okay? Sorry, you can't see that. There we go. Okay? So from there, I'm going to do my addition, press equals, and then divide by 8. So 6 plus 16.6 equals, divide by 8, 2.8-ish. And then 6 minus 16.6 divided by, equals, and then divide by 8, a negative 1.3. Okay, so we can see these are our solutions. If our directions, like they are for 18, I'm going to graph it, I would graph it over here because that's our third one, are to graph it. I can do so now. I'm going to put my y-intercept at negative 15, so this will be negative 5, negative 10, negative 15, there's my dot. Here, my vertex is going to be over 0.75 down to 17.25. So I'm going to go skip count by ones here. That way I won't have to label it. Okay. But here again, we're going by 5s. So I'm going to go over to 0.75, it's a little bit less than 1, and go down to 17.5. We'll eyeball it as being about there. Okay? Especially if this is negative 20. That is my vertex, meaning my axis of symmetry is right there. Okay? Here, I can reflect it on the other side. And this is what I have so far. Now, clearly, I can't tell where my x-intercepts are, which is why I did all of this work. Now I know where my x-intercepts are pretty much exactly. This isn't a perfectly exact answer because our number here is irrational. Okay, the square root of 276 is not nice. So I'm going to go over to 2.8, which is approximately there. There's one of my zeros. And then I'm going to go to negative 1.3, negative 1.3 right there, sure. This now is the graph of my parabola. Okay, so again, y-intercept, vertex, x-intercept, pick 3 strategies, one of the 3. I like the quadratic formula because it works every time, even if we have irrational numbers. You could factor, or you could complete the square. Let's look at doing number 20 or 21, and then maybe we'll only do one more example after that. So in 20 and 21, they ask you to take these zeros, or these roots, they are the solutions, okay, to the equation, and tell me what equation it came from. So we have, as number 20, 5, 6. Oops, it's not a coordinate pair. This means x equals 5, and x also equals 6. So to work backwards to this, we're going to set it up into its factored form, and then we're going to FOIL it. Always starts with an x. Now, if we want it to be x equals 5, we want to get this to be 0 because we set each of these to 0. So we move our 5 back over here. We'd subtract 5. So we're going to have a minus 5. Because again, if we set that equal to 0, here we would add 5 to get our x alone. And we know it's going to equal that. So that means this must also be the opposite sign, a minus 6. From here we FOIL first, x squared. Inside, minus 5x. Outside, minus 6x. And then last, negative times negative is a positive. 5 times 6 is 30. So we're left with x squared minus 11x plus 30. And then for it to be in standard form, it must have an equal 0. Okay? So to sum that up, I want you to make sure you try 21. You're going to take the two numbers. You're going to put them in factored form by flipping the signs. You're going to FOIL it out, combine your like terms in the middle, and make sure you set it equal to 0. All right, I'm hopping onto the back, number 26. The directions are to take this equation and solve it by factoring. So here we don't get to choose what strategy we want. We have to use factoring. And factoring is one we have not done for a while. Okay? If it asks you to factor on your test next week, hopefully you remember how to do it. I don't mind giving you a little hint on the first step, but once I give you that first step, you have to know what to do. Okay? So factoring always starts out with A times C. So 2 times a negative 24 is negative 48. So we're looking at what two numbers multiply to negative 48, but are going to add to a negative 2, our B value. Okay? So I'm going to do this by listing out, whether I do it literally or mentally, all of the factors of 48. Now, one must be positive and one must be negative, okay, in order to get that. And I want them to be 2 spaces apart from each other, the absolute value of each of them. So if I think about this, let's see, 48 could be 4 and 12. Those, however, would give me a positive 4 and a negative 12 together are going to be a negative 8. That's too large. Okay, so 4 and 12 will not work. I could do 6 and 8. Okay, 8 being negative because I need my answer to be negative, so the bigger number should be. If we have positive 6 times negative 8, we get negative 48. And if this is negative and this is positive, the sum is a negative 2. So these are my 2 special numbers. I'm going to take those, now that I've found them, and I'm going to replace my middle piece with these 2. So I'm going to get 2x squared plus 6x from here minus 8x from here minus 24. I kept my c the same. So I took this b and I broke it into 2 pieces. If you think about the example we just did, we combined like terms to get our b value. Here we just expanded it out into those 2 pieces again. Now we're going to factor by grouping. So we ask ourselves, what can come out of each of these pieces? A 2 and an x. If we take a 2 out of this, we're left with a 1 as a coefficient, which is invisible. If we take an x out of this, we're left with an x. If we take a 2 from this 6, we're left with a positive 3. And if we take the x out, that's all we have, is that positive 3. Because we have x plus 3 here, we must have x plus 3 on the other side. So we're going to ask ourselves, how do we go from a negative 8x to an x and a negative 24 to a positive 3? And there should be one number they each have in common, a negative 8. The negative will change the sign. And if you think about it, 24 divided by 3 is 8, and 8 divided by 1 is going to be that 8. Okay, so those are our pieces. We're almost done. This is a long process. We take this, it goes in one of our parentheses for our factored form. We take our other chunk, 2x minus 8, and that's our other piece. Now we set each equal to 0. So we minus 3, we have x equals negative 3. Now we're going to add 8 to get rid of this, and we're going to have 2x equals a positive 8, because 0 plus 8 is 8. Divide by 2, divide by 2. We have as our other solution, x equals 8 divided by 2, which is 4. Okay, sorry if that's a little hard for you to see. So to review factoring, we're going to do our AC first. What multiplies to that but adds to our B? Find our 2 numbers. Split this into 4 pieces. Factor by grouping. Put it in factored form, set them equal to 0, and solve. Okay, it's a bit of work. We haven't done it for a while. But you're going to be guaranteed to get only rational answers if they ask you for this strategy. You can't get irrational ones, and you're certainly not going to get imaginary because you can't come up with numbers that will work. Okay. Speaking of imaginary numbers, hopefully you can simplify anything that has a negative on the inside. If you see a negative on the inside, you pop it out as an I. If you have a number left in there, you should break it into the other pieces that you can. 8 can be broken into 2 and 4. 4 can be factored into 2 and 2. This pair comes out, and this is going to stay inside. So we're going to have 2i root 2. If we need to simplify our imaginary numbers. Again, we can't have a negative inside our root symbol because that is the definition of an imaginary number. You can't have some number times itself equaling a negative. Adding and subtracting, you just add the real pieces and add the imaginary pieces together. Subtracting, you just subtract the real pieces and subtract the imaginary pieces in the correct order. Multiplying, you'll need to FOIL. Okay, I'm not going to do these problems for you because there's only one of each, so I want you to try it. Okay, Number 33, which is foiling, because you're multiplying two complex numbers. Try it. We'll go over it if you want to before your test to make sure you have the right answer and the right strategy. Scooping down, we're going to look at 46, and then we'll do 52 as our last problem. So for 46, it says solve each equation by completing the square. So if you have x squared minus 6x minus 7 equals 0. To complete the square, we're going to move our 7 over and find a new c. So we have x squared minus 6x equals 7. We added it to each side. I'm going to take my b and I'm going to half it, which is going to be negative 3. And then I'm going to take that number and I'm going to square it. Negative 3 times negative 3, well, that's 9. That number is added to each side. I then take this new perfect square trinomial and I'm going to put it into its factored form. A perfect square trinomial is always the same parentheses times itself. And then we know a shortcut for this. It's going to be x minus 3, just half of our b. Negative 3 times negative 3, if we squared it, it does equal our positive 9, so we know we're in good shape too. And that should equal 16. To get rid of the squared, I square root each side. You guys are really good at this. Now we're left with x minus 3 equals plus or minus, because the square root, it could be positive or negative. And then the square root of 16 is nice. Okay, it's a very nice number. It's 4. We're going to add 3. Add 3. So we're left with x equals 3 plus or minus 4. 3 plus 4 is 7. 3 minus 4 is going to be a negative 1. Remember, solutions can be written like this in your curly brackets if you need to. So completing the square, move our old c over, find our new one. Rewrite it in its factored form, square root each side, move our other constant, that's with x, to the other side, and solve twice. Okay, you might get one solution twice, or you might get two totally different ones. Try your best. You only have one other one you need to do on your own. The last one is of the new stuff that we did in class last time, the discriminant. So let's write down our equation. We'll do, like I said, 52, the last one on the page. So pretty much if you watch this video, you have almost half of the work that you were supposed to do in class and or for homework done. So hopefully you watched and hopefully you filled out some answers. 52 is x squared plus 4x minus 32 equals 0. The directions are to A, find the discriminant. B, tell me what that discriminant means about our roots, which is about our solutions. And then lastly, find the exact solutions by using the quadratic formula. And again, the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. Okay? So, A, our discriminant. There are two problems like this on your test, guaranteed. Discriminant is this piece inside your equation. Know it, learn it, memorize it for next week. Okay? So I'm going to solve for that right now. I'm going to do b squared, which is going to be 16, minus 4. My a is 1. My c is a negative 32. So inside here, I now have 16. 4 times 1 is 4. 4 times 32 is 128. Okay, negative times negative is a positive. 16 plus 148. Sorry, 128. My bad. Okay, I'm going to add those. My sum is going to be 200. Just kidding. 100. 8 times 6, 8 plus 6 is 14. That, 2, 3, 4, 144. Oh, that worked out nicely. Okay? So my discriminant is 144. Now I'm going to look back to my note sheet. It had a table with 4 sections on the top. I'm going to look at it. There are 4 options. It's positive in a perfect square, which means it's rational. It is positive but a non-perfect square, meaning that your answer is going to be irrational. Maybe it's equal to 0, this number. If it's equal to 0, then you have some number plus 0, some number minus 0, meaning you only have one solution. And then lastly, it could be a negative number. If we have a negative inside our square root sign here, that means we're going to have an imaginary solution. Okay? So Here, it's positive and it's a perfect square, meaning we're going to have a rational answer. Okay? Now the last bit is to solve it. So I'm going to plug in my 144. 2 times my a is 2 times 1, which is 1. And negative b is just negative 4. So to finish this up, the square root of 144 I know is 12. So I have negative 4 plus or minus 12 over 2. Negative 4 plus 12 is 8 over 2, which is 4. And then negative 4 minus 12 is a negative 16 over 2, which equals negative 8. My two solutions, negative 8 and 4. These are both rational numbers. They're either whole numbers or nice fractions, okay? There's no gnarly decimals I had to round anywhere, or it would be irrational. Lots of information I threw at you, lots of information on this test. So I want you to do this. Very seldomly does everyone in this room do their homework. It's half done for you right now. Please, over the weekend, Monday night, finish it, okay? The next time I see you folks is Tuesday. After school on Monday, I will be doing a comprehensive review session where we will go over all of the rest of the other answers. So if you don't want to do this homework and you're worried you don't know it, please show up after Day of Caring on Monday. I will be here and I'll be going over all the rest of the answers on this sheet. Okay? But try, give it some effort, and see if you can do some studying this weekend.